84 years.
There you go. Well, okay, there is one thing about that musical that relates to this class. It is read instructions and also agreements and contracts very, very carefully. The story goes like, so a guy mistakenly signed up for pirates, as an apprentice of pirates instead of an apprentice of pilots because the nanny heard it wrong from the parents. And the contract says, you need to serve or be under the contract for 21 birthdays. Not 21 years, 21 birthdays. So, so at age 21, the guy thought, okay, I'm clear. I can now go back to my normal life and try to catch the pirates instead of being one of the pirates. And then the pirates came back and said, nope, you're not quite done yet. You have only served 5 birthdays up to this point, because the guy was born on the leap day. So it was, yeah. That's interesting. That's how the whole story goes. It's an interesting musical. There are lots of interesting songs. All right, so let's go ahead and get started with the test. So what I'll do is I'm just going to take out each question here. Unless someone asks me to cover multiple versions of the same question, I'll just pick one of each question, one version of each question, and cover that. So for the first one, I'll just use version A. And here is version A of the test. They're all very similar. Okay, you should not be seeing a whole lot of differences between the versions. Do you want me to just talk about it, or do you want me to actually use? Just do it. Okay, we'll do it.
I want us to try to figure out what my score is to do it.
See how much time it will take me to do it, huh?
No, what my score is, since we don't know what our score is for the test yet.
Indeed.
I know if mine looks like yours, I should get 100%.
Should, but you won't. It's going to give out 100%.
All right. So what I will do is I'm going to replicate the program first. And there's a typo here. It should be and while and not and if. I put the correction on the whiteboard too. That's x minus 1 and while, and then we'll fix the indentation.
Unexpected if statement. What to do?
One more.
Unexpected if statement on line 5. You returning it back? No. It's what you get. The dash.
All right. So we have comments. We have line number. And in the test, let me use the same column too. So, since we only have one variable, it's just x. All right. So we'll get started with this one. And the precondition should be unknown because I didn't tell you anything about x. So that's important. Okay, you have to say that x starts with an unknown value. Just like we always do in the class. We start with line 1. Line 1 is going to put the value of 64 into x. Line 2 is the beginning of the loop. It checks whether x is greater than 1 or not. Let me show you the other window. Okay, there we go. All right, because it's just a little bit bigger here. It shows better. Okay, on line 2 we have to evaluate x is greater than 1 is true. Okay, so we go to line 3. Line 3 evaluates another condition. X is greater than 3 is true. We go to line 4. Line 4 decrements 20 from 62. It becomes 42.
42.
Oops. Well, I said 42. I keep typing the wrong key. Okay, now we have the first question here. Where do we go back to? We know at the end of the action of a loop, we have to go back to the beginning of something. So where are we going back to? We're going back to line 3 because that's the beginning of the inner loop, okay? Because it's just like parentheses, you have to match the end with the beginning. So in this case, we go back to line 3. At this point, x is greater than 3 is still true. We go back to line 4 again. 42 minus 20 is 22. Go back to line 3. X is greater than 3. It's still true. Go to line 4. And it becomes 2 at this point. Go back to line 3. X is greater than 3 is no longer true. It is now false. So we get out of the inner loop. Where do we end up at this point?
6.
Line 6. Very good. On line 6, we just decrement x by 1. So x becomes 1 at this point. And then where do we go?
2.
We go back to line 2 because the outer end while has to match the outer the beginning of the while. So we go back to line 2. X is greater than 1 is false. So then we get to post. We're all done.
Yeah. I thought I got that one so wrong. Man, that's a relief.
You got it right, right?
Yeah.
All
You
right.
got it right. It's just I didn't put it on there.
Okay, so what I will do, when I grade questions like
I
this,
need to go back
what
to
I'm
that
looking
too.
for is not like line by line or column by column or cell by cell matching what I have here. If it matches perfectly, thank you. It makes my grading job so much easier. If it's completely missing, like there's nothing written, thank you also. It also makes my job a whole lot easier. The worst part is, what if it is partially right? Like a few lines are right and then something went wrong and then the trace just kind of go wrong from that point. What I'll be looking for is why or what is the mistake, okay? If it's really a simple mistake like the comparison, you just have one more iteration, you say x is greater than 1 is true at this point and go for another iteration, I'll probably just deduct a minor amount of points because it seems that for the rest of the trace you understand the concept of nesting, what is a loop inside a loop, how to get inside a loop, how to get out of a loop. So those are the main concepts that I'm looking for. Okay, so for the most part, I'll be looking for the understanding of concepts and the ability to apply the concepts. Okay, any questions? No questions? Is this similar to the practice test?
Yeah.
Question 1 of the practice test is pretty similar. I mean, things are flipped around a little bit because in the practice test we have a conditional statement inside the loop. In this case, the outer loop only goes through once. So in a way, it kind of behaves like a conditional statement, but it really is a loop. It's just that we don't need a second iteration in this case. All right. So I'll go ahead and save this so that you have a copy too. If I upload when I upload the file. If you guys want me to upload the file, you have to kind of remind me to do it. So this is exam 1, question 1. And now we can move on to the second question. Okay, for the second question, I'm going to pick variant D. And this is the kind of question that you guys like the most.
We like it too much. Oh, we love that.
Okay, but I think it's really not that much different from the one in the practice test. In terms of, there's really not so much I can do about the type of question, or it's really hard to trick it out anymore. All right, so we'll go ahead and just copy the question here. X gets y plus 1. Line 4. X gets x plus x. Line 5. Z gets y plus 1. And then on line 6, in this case, we have y gets 3. Okay. The post condition that is given to you is this. Now for this one, the different variants, they look different, but they all basically ask about the same thing. Post 6 is x equals 12, and z equals 6, and y equals 3. As I said in the class before, in the practice test, you don't have to explain how you get all the way back to pre-3, even though a step-by-step derivation will help you understand how you got back to pre-3. So what I would do is I'm going to go through it, just step by step. I wouldn't use, any math notations and stuff like that, but I would just try my best to be step by step here. So if I know post 6 is, knowing that x equals to 12, z equals 6, and y equals 3, what can I know for sure right before line 6 executes?
X equals 12. Z equals 6.
So the only thing I have to toss would be y equals 3, because everything else, should still be true. Okay, so we'll just keep everything else, x equals 12 and z equals 6, they can be kept, but y equals 3, I don't know anymore. Because y equals 3 or y gets 3 as an assignment statement is not undoable. There's no way for me to reverse that operation to find out what y was before the assignment. So that's why you kind of have to let go of that term. Okay, so post 5 is pre 6 because these two lines are sequential. Now the question is, what is pre 5? Well, let's take a look at what pre 5 is doing. Pre 5 is saying z gets the value of y plus 1. And as a result of that, z became 6. So the question is, what do I know at this point about the values of y, and before line 5, what do we know about?
Y equals 5.
Hmm?
No.
Okay, let's think about this. We know that z becomes 6 because it is y plus 1. So what does it tell you about y itself?
Y equals 5.
Y has to be 5. Okay. What about x? Do we have to do anything about x?
No.
We don't have to do anything about x because x is not affected in any way. So we can know that y equals 5. What about z? Can I say something about z before line 5?
No.
No, because it is not reversible. There's no way I can reverse this operation. So we go to post 4 equals pre. Whoops. Oh, I got it wrong. It's post 4 equals pre 5. Okay. So what we know now is in post 4, we know this is post 4. Right after line 4 executes, this is what we know. Can we say something about pre 4? In other words, after I change x to become x plus x, it had a value of 12. So before I perform the operation on line 4, can I do do I know what is the value of x before that?
6.
It will be 6. X equals 6. I didn't do anything about y. I didn't do anything about z. So that's the best I can do. Are we still doing okay so far with this? Okay. Then we go to post 3 equals pre 4. So that means, right after line 3 executes, we know x equals 6 and y equals 5. Is there anything we can do here? We can do something about it. Okay, pre 3 is, what do we know about x right before line 3? Nothing, because we just changed it. So the only thing we can keep is y equals 5. That becomes the precondition of everything. Now, you can probably do it in some other way, without reasoning it out the way I did, or writing it down. All you have to do is to tell me what is pre 3, and then from there, do all the forward derivation so they can end up on line 6 and give me the same result as what we have in the test, in the question. Okay. So now we are going forward again. Now going forward should be somewhat familiar because we have talked about this quite a few times. So starting with pre 3, how do I get to post 3? Okay, first of all, there are 2 questions you have to ask. Depending on the answer to the first one, you might have to ask a second question, but in this case, only one question is enough. The question is, does the right-hand side of line 3 refer to the left-hand side? The answer is no. So that means which rule are we going to use? Use the forget rule. Okay. So now we have post 3 equals the forget operation applied to pre 3. What are we forgetting? Are we forgetting x or are we forgetting y? We're forgetting x because that's the one being changed. And after this, what do we know? Okay, x equals y plus 1. Okay, very good. So now we just have to kind of flush out the details here. What is pre 3? Pre 3 is just y equals 5. So that means I don't have anything to forget because the precondition does not mention anything about x. So I get to keep the entire precondition. There's nothing to toss away in this case. So that means the forget operation really doesn't do anything. And now we can say x equals y plus 1. But remember, we have to take this one step further. Every time you can see a particular variable having a particular constant, you know the exact value, you have to resolve the other ones that depends on it. Okay, so we have to take this one step further and say that y equals 5 and x equals 6. Okay, Now that we have post 4, then we can say pre-4, we have post 3, then we can say pre-4 equals post 3 because they are sequential. Even if you don't say that they're sequential, it's fine. Okay, as long as you say something about pre-4 is the same as post 3, that is what I'm looking for. Because otherwise, there's no linkage between these statements. So you got to give me a link and say, okay, I know the precondition of this relies on the post condition of the previous one before. Okay, now that we know post 4 is this, how do we get to, now that we know pre-4 is this condition, how do we get to post 4? We ask the same question. The first question is, does the right-hand side of line 4 refer to the left-hand side? The answer is yes in this case, and I have to change the line number to line 4. So if the answer is yes, then we have to ask a second question. Is it reversible? Just because the right-hand side refers to the left-hand side does not always say that it is reversible. In this case, is it reversible? It is reversible. Doubling something is reversible by dividing it by 2. Okay. So then we have to answer the second question. The right-hand side, f of x equals x plus x, is reversible. The inverse function of f is just x divided by 2. Are we doing okay so far with this part here, finding the inverse function, how to reverse the operation? It is not x minus x. Okay, the reverse of x plus x is not x minus x, because x minus x itself is not reversible. It is always 0. Okay. So it's not always the case when you see a addition, then you just apply a subtraction to reverse it. All right. So now that we have this, we can try to derive the post condition. So we'll say post 4 is the result of the substitution operation applied to pre-4. We are looking for occurrences of x, and then we replace it with f prime of x, or the reverse function applied to x. And then the next part, just copy and paste a bunch of stuff, which you could not do in the exam because you have to do it by hand. Okay, x divided by 2 goes here. And then we just go ahead and perform the substitution. The substitution doesn't affect y equals 5 because it has no mentioning of x whatsoever. But the second one does, so we replace x with x divided by 2. But x divided by 2 would still be equaling to 6, because we can keep that part. You can leave it the way it is, just say x divided by 2 is 6, or you can say x equals 12. I think it's easy enough to say that x equals 12 in this case, so I would just go one step further here and just say x equals 12. Any questions about post 4? Now that we have post 4, we can say pre-5 is the same as post 4, and then we can try to derive what is post 5. What do you think about line 5? Does the right-hand side of line 5 refer to the left-hand side?
No.
Nope, does not. So we can answer the question, change the line number to 5. So which rule do we use? Yep, use the forget rule. So that means post 5 is the result of the forget operation of pre-5 applied to which variable? We have 2 variables on line 5. Z to z, because z is the one on the left-hand side, is the one getting changed. Then we can say z equals y plus 1 after that. And then the rest is really just, finding out what is pre-5. Pre-5 is this condition here. I'm going to make this a little bit wider so we can see the whole thing. And also make it go up a little bit. There we go. It's hard to grab that corner to make it resize. Okay. All right. Is there anything to forget here? Did we mention anything about z in pre-5? Pre-5 is just post 4. It doesn't say anything about z, so there's really nothing to delete. There's nothing to forget here. So we end up with x equals 5, y equals 5, and x equals 12. We also have one more thing. We also know that z equals y plus 1, but remember in the class I said if you can resolve the actual value, you should go that one step further and resolve the value. So in this case, we can resolve the value because we know what y is already. So that means z equals 5 plus 1, which is 6. Any questions about post 5? Okay. Now we are down to the last step. Pre-6 is post 5. And we have to ask the same question again. Does the right-hand side of line 6 refer to the left-hand side? And I'll refer back to that line first so that we can answer the question correctly. Okay, this is line 6. Line 6 obviously, on line 6, the right-hand side obviously does not refer to, the right-hand side does not refer to the left-hand side. So we'll just say it is no, and we have to use the forget rule again. So post 6 is the forget operation applied to pre-6. We are forgetting anything that mentions y, and after this y equals 3 because 3 is the right-hand side of the assignment statement. And then after this, it's really just a matter of copying what was stated before. And now we say y equals 3. But the forget operation this time actually has something to forget because we knew that y equals 5 before, but we cannot make that claim anymore because of the assignment statement. So we only have x equals 12 left and z equals 6 left. But we also know that at this point y equals 3 because of the assignment statement. And that's it. That's the end of the second question. Yep.
Can you go back to pre-3? So can we set that like pre-3 s equals some value in there?
It depends on what you say about x, because we really don't know anything about x.
Yeah, just say s equal 1.
No.
But it's still true when you go to the rule, because the whole 3 you forget rule, right? Because the right hand side did not refer to the left hand side, so we're gonna forget the s value.
But it is still wrong to claim that x equals 1.
But in this case, if your pre-3 s equals something, is
but that's not the only thing that will determine your grade, because your grade also depends on the first task is figure out what is pre-3. If your pre-3 is wrong, then it is wrong. That's a part of your grade. The rest of your grade depends on whether you can carry out the actual substitution and forget operation and identify which operation you have to perform.
But how can you know it's wrong?
Because x equals 1 states that x has to be 1 as a precondition of line 3, which is not the case here.
But you don't know. But how can you know that?
It can be 1, but it doesn't have to be 1. Yep.
I think it's one case that, before that, we don't even know that x even exists. When we're doing the new line, we're just adding a new variable and giving it a value.
Right. In a programming language where the first use of the variable creates the variable, yes, you're absolutely right. We may not even know whether x exists at that point.
You can't assume anything about the variable if it's not even mentioned.
Yep.
So if I put that x equals 6 and z equals 6 for pre-3, that would be marked wrong too.
If you say anything about x, you will have points deducted because we really cannot know what x is. But it's not going to mess up your whole thing because I'm still looking for your derivations. Most of the points of this question will be in your derivations. In other words, can you go from the precondition of line 3 to the post condition of line 3? As long as you perform that step correctly, you will still get most of the points. Okay? Yep.
It's funny, I put down a value for x, but in my derivations, I didn't use x.
In your derivation, it depends on which variant of the question you get. If you get exactly this one, you can see how we lost x here. Because if you had x, the first operation, we would have done something and forgotten the value of x. So it is correct. So what he said was correct. Even if you stated anything about x, it would not have affected how you get to post 6. But since part of the question is to find out what is pre-3, you still have to make that part right. That is still part of the score. So it's only partial. It's not. I'm not going to say oh, you got pre-3 wrong, so I don't even bother to grade the rest of the questions. I will still grade the rest and look for other things that I should be looking for. But as far as that particular part is concerned, that you will get some points deducted. Okay. Yep.
Is it okay if you do the other questions for the test? Because I have some different questions.
Yeah. There are 4 different versions of this test. Let me get to that part. But I do want to. Yeah, go ahead.
Sorry, I was just going to ask on your say post 3 there, the second forget line. If we jump from that all the way to the 4th line instead of including that 3rd line there.
That's fine.
Okay.
Yep, that is fine. Yep. Yep.
What if we started on the first line of post 3 just stating the value of x instead of stating it as the right-hand side of the operation?
You mean here?
Yeah, so, no, over to the right.
Over to the right here.
Yeah, that right there. So instead of saying x equals y plus 1, we just went ahead and said x equals 6. Is that wrong? I mean, skipping
That'll be
steps, I
fine.
understand
That'll be
that.
fine because you already know y equals to 5, so you're just doing the substitution right away there. So that will be fine. Yep. But I do want to emphasize, why I'm so picky about pre-3, even though the pre-3 being wrong would still lead to the same conclusion. Why is it even important? It's because we are doing this. Why are we doing things backwards anyway? Just because it makes a good question and hard enough for a test?
No, that way we can, if a program's screwed up,
Yep.
we can go backwards and figure out where it's screwed up and what line it's screwed up on.
Exactly. So when you execute a program, if you imagine this line is the line of execution or the lines that execute during the execution of a program, at some point the program is wrong. Okay, this is the first point where you recognize something has gone wrong. So you want to go back and find out, okay, at which point has the program gone wrong? If you go back like this, then you'll be doing exactly the same thing that we have been doing for this question. You're basically deducing backwards and say, what can I possibly know about the variables as I walk my way backwards from the point where the program is broken? So as you walk backwards, let's say we are interested in at this point here, then whether you can say x equals 1 or not becomes a very important thing. Because if you claim x equals 1, that means you know that at this point, you know for sure that x has a value of 1. If you know that x has a value of 1 at this point, you can continue and go back even some more. And if it gets to a point where there's a decision to make, then you can go on to the wrong branch, because you can say, oh, I know for sure x must have come from this branch and not the other branch. On the other hand, if you don't say anything about x, then you cannot deduce anymore. At some point, you just have to kind of throw your hands up and go like, okay, I know nothing about the variables anymore. I have to stop at this point. So whether you claim x equals 1 or not, even though it doesn't change the end result at this point, it does change when you continue this process to go back to line 2 and line 1 and so on. And that is why I'm so picky about whether x equals 1 is in the precondition of line 3 or not. Okay, I hope you guys understand why I'm being picky. I try not to be picky on little things, but this is not a little thing. I think conceptually this is an important concept. Okay. Okay, so you wanted me to go over another question. What is yours? What does line 3 look like?
Line 3 is the same as the one you have there. The only difference is that for post 4 it's x plus y instead of x plus 2.
Okay, so let's go take a look at the another variant. Now, which one is this? Is this D or not?
That's D.
That's D. Okay, we'll go back to. You're probably dealing with C. I cannot remember. Is that the one?
I don't know if I know if that is the other one. Yeah, that's the same one C has.
Okay, so let's deal with this one here. Now this one is kind of interesting because we don't have x plus x. Instead, we have x plus y here. So we'll go ahead and work on this one. So now I have to. Well, since I copied the whole question, that's fine. Because I don't want to make anyone confuse anyone in the class, because I'm dealing with 2 questions that are very similar. Okay, so I'm just going to replicate the question here. and we'll talk about it. Line 5, y, z gets y plus 1, and on line 6, y gets 3. Okay, so with this one, going backwards is about the same process. So we'll go ahead and just do it quickly here. Post 6 is x equals 5, z equals 3, and y equals 3. Okay. What can we know about pre-6? It's the same part, though. This part is identical to the one before. We just cannot say anything about y anymore because the operation on line 6 completely erases the previous value of y, and there's no way to reverse that operation. So that means we end up with x equals 5 and z equals 3 as pre-6. Post 5 is the same as pre-6 because the two lines are sequential. What can we say about pre-5 in this case? Pretty much the same thing, right? Because we know that z is 3 as a result of y plus 1. So what we know is y has to be 2. But we cannot say anything about z anymore because y plus 1 is not reversible. There's no way to get back to the old value of z. Same reasoning as last time. Are we doing okay so far? Okay. So now we get to the tricky line, which is the line that is different from the other one. So post 4 is pre-5 because these two lines are sequential right next to each other. So the question is, what do we know about pre-4? Now pre-4 is, okay, we know x equals 5 at this point, and we know y is 2. So what do we know about x? X has to be 3. Okay, so x equals 3, and y equals 2 in this case. And then we can now relate post 3 to pre-4. And according to this, we have to find out what is pre-3.
Y equals 2.
So in this case, y equals 2 and x equals 3 are consistent. They're consistent, but we have to throw 1 away.
Yeah, y equals
right?
2.
We have to throw 1 away because line 3 destroys the original value of x. So there's no way for me to go back and find out what was the value of x before line 3. So the only thing I can keep is the fact that y equals 2 as pre-3. Is that answering the question?
Yes.
The forward derivation would be almost identical as the other one. The only difference is the inverse function is x equals, x gets, f of x is x, f prime of x is x minus 2 instead of x plus 2, because y has a value of 2. Okay. All right. So are we okay with question number 2? There are 2 other variants too, but they are pretty similar in terms of the steps and also the constructs. There's really only so much I can do. I can only have the right-hand side refer to the left-hand side, or have the right-hand side not refer to the left-hand side. Those are the only only two things I can do as variants of the test, of the question. All right, so that one is done. And let's go back to my. Where's the other? Right there. Okay. So we are now moving on to question number 3. For question 3, I'll pick variant A. Okay, so this one is just a trace. And in the trace, I give you a precondition. I forgot to change the line number from 1 to pre. But I wrote that on the whiteboard too, is to change the line 1 to a pre. Yep.
And in this one, you had like 5 and then jump to like 7.
Well, we'll take a look. Okay. So what we'll do is we'll trace at least one of the test cases.
I have a question.
Yep. Go ahead.
I just started on that line. I thought you said just skip pre altogether, just go for it. Not
Yeah,
change
that's what I
it.
thought. That's what I did as
Because you didn't
well.
put pre, so is that okay?
Oh.
I said something. There was there's no pre line here, so I just started at line 1.
Okay. Well, I guess I'll give you credit for that too.
Yeah, credit.
It doesn't really change anything, as long as you don't go from line 1 to post right away, it'll be fine. Okay, line number.
You don't get this
Comments.
negative points for that.
Line number, we have X and Y. Okay, I'm going to use the same example here. So we have 2 and 4. So we have line 1, line 2, and line 4. So we are starting with line 1. Did you put anything here?
Yeah,
On the
put
comments?
true.
Okay, all right, very good. Okay, that's because that part is important. Even though I start with line 1, you still have to say something about the condition and what to do next.
It's true.
It's true.
True.
It's sad but true. It's a line of lyrics from one of the songs in Lion King. You know, the hog, the warthog, sang a song.
Oh yeah, about
Yeah.
him because he falls in love with the girl line.
Yeah.
And
I don't even remember that movie.
there's like 4, but I remember.
Yeah, you can tell how I cannot keep track of everything because I use all my memory up to remember all the not so important stuff, like Lion King songs and stuff. All right, so where do we go from here?
Go to line 2.
We go to line 2. Excellent. Okay, line 2 is good. So line 2 says x is less than y is true in this case. So where do we go? Line 3, right? Line 3 adds 1 to x. X goes from 2 to 3. And then where do we go? Then we go to line 5. Very good. Because these two conditional statements are completely independent. They're one after another. They're sequential conditional statements. There's no else here. Okay? So we go to line 5. Line 5 asks a rather not so intelligent question because we just compared. But x is greater than y is false. And then where do we go?
7.
No.
Line 1.
If it is false, we go all the way back to line 1. Because there's nothing after the conditional statement from line 5 to line 8. So that's why when that condition is false, we go straight all the way back to the beginning of the loop. So at the beginning of the loop, we still ask the question, 3 is different from 4 is true. So the second iteration will do about the same thing. Okay, x is less than y is true. We go to line 3, x goes from 3 to 4. And then we go to line 5, x is less than y, x is greater than y is still false because now they equal to each other. Then we go back to line 1 again. Line 1 says x is different from y, this time it's false. And then we go to post. Okay? Yep. Sure, I can definitely do that. So let's say, oh, I did something wrong here. I forgot to rewrite or replicate the algorithm. Okay, this is exam 1, question 3. Is it okay with you guys if I name it as exam 1 question 3? You guys know what is the algorithm? Okay. Let's go to sheet 2 and use that to track the other cases where the values of x and y are reversed. All right, so in this case, we'll change x to start with the value of 4, y starts with the value of 2. Is that good? Okay, all right. Well, the comments hasn't changed because they are still different. X is different from y is still true on line 1. So now we go to line 2. This is where the differences start because in this case, x is less than y is false. So we get out of the first conditional statement, and then we start with the second conditional statement on line 5. The second conditional statement is asking, is x greater than y? The answer is true, because 4 is greater than 2. We go to line 6. We add 1, we subtract 1 from x, so x goes from 4 to 3. And then, where do we go? 1. Oh, sorry. I skipped that one line.
But what happens if I write down line 6 right here?
I will probably just understand it as, you know,
Okay.
as long as, if you say line 6, but as long as
Yeah, I
the
do.
effect of that line is consistent with the actual line 6, I'll count it as okay too.
Okay.
So I will just call it line 5, 6/7.
Okay.
Okay? Okay, but are we doing okay so far at this point? Okay? So after line 7, where do we go?
Like 1.
There's nothing after the conditional statement, so we have to go all the way back to the beginning of the loop on line 1. Reevaluate whether they are still different, and they are still different because they are, one is 3 and the other one is 2. We go to line 2, x is less than y is still false. We skip the first conditional statement. We go to line 5, x is greater than y is still true in this case. So we go to line 6, we decrement x from 3 to 2. Go back to line 1. They are different is false, and then we get the post at that point. Okay, any questions about this trace? So in this particular case, I'll be looking for a few things. I always look for the exit condition. In other words, the only way to get out of a loop is to go back to the beginning of a pre-checking loop, confirm the condition is false, and then you can get out. So that is worth some points already. In this case, knowing that when the first conditional statement is done, you have to start with the second conditional statement, that's worth points as well. In this particular trace, going from line 2 to line 5 directly is worth some points. In sheet 1, it is going from line 3 to line 5, because those two conditional statements are on the same level and they're independent. They're sequential statements, basically. Okay. Are there any questions about number 3? Yep.
If we didn't have the indentation on number 5.
On number 5.
So then, basically, after you went into the first part of the while loop, line 2, and then you went through that, then you go back to 1, and if that was, then you'd only have to do that part because there's 2 branches of that loop.
Okay, if I were to draw a
Say
picture,
if there was no indentation.
the indentation is only there to visually help you understand the structure of the program. In other words, I could have presented this with no indentations whatsoever. It doesn't change the meaning of the program. It just makes it harder to understand.
All right.
Okay? So the indentation doesn't really do anything regarding the meaning of the program. It just makes it easy to read. But in terms of what this algorithm looks like, this is what it looks like. I think it is kind of important to understand what it looks like. Okay, so we have a while loop, which means we can come back from a later point, or I can come straight in the first time. The first thing we do is a conditional statement. Every conditional statement means there are 2 branches. So in this case, we have one branch to do something here. The other branch doesn't do anything. It just skips the operation, and then these 2 operations merge. And then we have another construct that looks exactly the same way. It's just the question is different and the action is different. So we have another branch here that has something to do for the then branch, but the else branch has nothing to do, so it all merges like that too. After the second conditional statement, then we go all the way back to the beginning of the loop, like that. And I forgot to write the exit. This becomes an infinite loop, doesn't it? Yeah. Now we have to make an opening, a little escape hatch, and that is our exit path here. So that's what it looks like because the 2 conditional statements are sequential. This is our first conditional statement, and this is our second conditional statement. After the first one, you always have to go through the second one.
All right, so in that loop, we do both of those if statements. When we're going through that loop, we go through both.
Yes, you have no choice but to go through both statements, even though if the condition is true for one, it is going to be false for the other one. So even so, you have to evaluate the condition again. Yep.
On my both of my traces, I don't know why, I kind of just, but the last going back to line 1 for some reason, I just figured like in my head, I must have figured that it was like a given or something that you just automatically,
In other words, you missed row 10, you just say post right here.
Yeah, I mean both of my traces are perfect, but I did that on
You will
both of
still
my
get some
traces.
points deducted because it is important to remember how you can get out of a loop is to go back to the beginning first, reevaluate the condition, and then you can decide to get out. Otherwise, there's no reason why you're out of the loop.
Yeah, I'm looking at that right now, and it would not even make sense.
It's partial credit. I mean, it's not going to be a whole lot of points, but there will be like minor points deduction.
Okay.
And that's what makes grading these kind of exams really difficult is to assign partial credit and then look for things too. I mean, I have to actually look at in each individual answer and look for okay, is there any sign that this person show that he or she understands this concept and be able to apply that concept. So that makes grading hard. And that's why I like either perfect answers or completely missing answers. It's like, yep, those are easy ones.
What about consistently wrong?
Consistently wrong.
I guess that's third, huh?
Consistently wrong is...
Well, if you're consistently wrong, that might mean there's something wrong with the professor.
Well, that would be consistency across students.
That's true.
Yeah.
If more than half the class make exactly the same mistake, it could be the professor being wrong in that case. Okay, we're down to the last question. So let's go pick, I don't know, variance C. Okay, there we go. And for this one, I'm just going to do it, in place. Okay, I know how much you guys like these questions too. This one, I don't think this one is really too hard. I mean, but is it harder than the practice exam or about the same?
I think it was about the same.
I think they're about the same. I mean, without the practice exam, I think people would be a little bit. I think the overall score, the average, would be lower without the practice exam, because people wouldn't know what type of question I'll be asking. But I think with the practice exam, I think it helps to prepare some people for the test. Not exactly everybody, but some people should benefit from it. All right, first case. Okay, how do we make z equal to 0? Well, x has to be non-zero, and y has to be less than 2. There are tons of cases like that. What about just x being 1 and y being 1? That'll do it. Okay, so we'll say x equals 1, y equals 1, and that will do the job. Okay. Moving on to the second case. The second case is how can we make z equals 1? We have to take the case where x is greater than 5. 6. Yep. And y can be anything. So it doesn't even matter what you put here, but you cannot put a question mark here. You have to give me a specific value.
Y has to be greater than.
What about star?
Star. Well, it has to be less than or equal to 2.
Oh, x has to be.
Y does.
Y has to be
Yes,
greater than 2. Otherwise, it will fit the first case. Yep. Okay. Very good. I missed that part. Okay. Does everybody understand why y actually has some constraints on it? It's because I cannot make it fit the first description. So as we go, we have to check all the other conditions and make sure that it will fail all the previous one and only fit that particular condition. Yep.
Yeah, but isn't the first condition says and, so both of them have to be true for the whole statement to be true?
Yes.
Yeah, but if you get y and y is true, but the first part of it is not true, then it's still false.
Say again.
Still different than 0.
The only thing you can do about this,
okay.
because you also have a constraint on x here. So if you put x equals to 0, x cannot be greater than 5 either. Yep. Okay, on to the third case. The third case is else if x is different from 0. Okay, so this means x. Okay, so that means y can be less than 2. Okay, y has to be less than 2, otherwise it will have fit the first condition already. So y has to be less than 2. Let's pick 1. Okay. What about x? Do we have any constraints on x in this case? We still have some constraints on x.
Can't be greater than 5.
Because x cannot be greater than 5. If x is greater than 5, then it would have, met the condition of line 3. Yes? Okay, go ahead.
Should it be greater than 2? Or y should be greater than 2?
Y, no, y, we don't want y to be greater than 2.
Then if
Oh,
y is
because it
greater
meets,
than x
yeah,
is-
okay, it meets the condition in that case. Sorry, I flipped the logic.
Yes.
Okay. Okay, what about x? 1 will work because it can be anything other than 0 itself. All right. There's actually an easier way to do it than just randomly picking up numbers. Yep, go ahead.
But if x is 1, then wouldn't line 4 execute?
If x is 1,
Because then x is... Oh, sorry.
yep, so that excludes that. Okay, so you can see it gets increasingly difficult because you have to make all the previous conditions false to make sure that it can only make this one work. Okay, so we are now on to line 7, the condition of line 7. Now some of these may not be possible. Remember, some of these may not be possible. Okay, can we make x greater than 5 and y is greater than x at this point?
No.
Why is it not possible?
Because x is greater than 5 is sufficient and necessary to satisfy 3. So if x
Yep.
is greater than 5,
Yep.
no matter what y is, we would already execute line 3.
That is correct because line 3 covers more. Okay, if you look at line 3 here, line 3 implies. Excuse me, I should take it back. Line 7 implies line 3 already. In other words, if x is greater than 5, I don't care how x and y relate, I would have executed line 4 already. So that's why line 8 is not possible. So what you have to do here is to say this is impossible. And then you have to give me a brief explanation because line 3 would have caught all cases where x is greater than 5. Do we have to say something about x is different from 0? I mean, x is different from 0 is here as well. Do we have to mention something about that too? Why not?
Because there's 4 cases where x can be, actually infinite cases if you go negative where x is different from 0 but not greater than 5.
X is greater than 5 implies that x is different from 0 already. So there's no need to mention that. Okay, what about line 9? Is it possible for x still to be 0 at this point? Yeah, it's perfectly possible. So x equals to 0, and what about y? Do we have to put some constraints on y here? We don't have to put any constraints on y because there's nothing about y that can affect the earlier decisions. So y can be anything. Okay, y can be 0, y can be 1, it doesn't matter what it is. What about the last case here? Is it possible? It's not possible because we have covered all the possible cases regarding which variable? X. Okay, because we caught all the cases about x being different from 0, and we caught the only remaining case which is x equals to 0. So that means that we cannot. There's nothing we can do to make that happen.
Last time you said we could use negative numbers. For number, it was last one, negative numbers, or use negative 1.
You can use negative numbers.
Is that maybe
X being negative 1.
possible? Yeah.
Well, we'll give it a try. Okay, we'll give this a run and say what if x equals to negative 1. Now, if x equals to negative 1, you also have to specify something about y. So what do you want to say about y? Y is 3. Okay. So what if x is 1 and y is 3? I have to come back and erase that later. Okay, let's take a look. X is negative 1, which is different from 0. Y is 3, which is not less than 2. So the first condition is false. It goes to the second one. X is negative 1. It is not greater than 5. It makes it false too. But the third condition would have been met. Because the third one only asks whether x is different from 0. Negative 1 is different from 0. Yep. All right. So that's it. I mean, do you guys want me to go over another one of these examples? I mean, there are 3 other variants, but they are very similar in terms of the answers are different, but they are similar type of questions. And And I have to undo the last two operations because I put this here, so I will just click like that, and say this is impossible because we have caught all cases of x, regardless of how x and y relate. Okay. Any other questions about the test? No? Okay. Let me save the file first, and then we'll go back and talk about arrays. This is, I'll just call it the same way. You can download this program for Windows. It's called Xournal, Xournal. It is available for Windows too. So if you download that program, you can open up the file the way I saved it.
When do you think you'll have the exams graded, like on Moodle?
Next Tuesday.
Next Tuesday?
Yep.
Okay.
For sure. Yep.
I think we're all kind of eager to find out what we got.
Well, you already know what you got.
Minor deductions, though. Let's see how
The
much
actual
it's
point values. Huh?
Yeah, exactly.
Yeah, that's what it was.
I think for this class, the average of the first test in the past, like 3 or 4 years ago, used to be like really, really low, and that's before I have kind of like settled down on the style of the questions. So the pre-test or the practice test is not even close to the actual test, so it didn't really prepare people for the actual test. But over the last 2 or 3 years, I think the average of the first exam is usually pretty good. We have the only question is, are there more people getting A's than B's, or are there more people getting B's than A's? And those would be like the two biggest columns if I plot out the distribution. C would be kind of like a distant third, and then D would be like the real minority would be the D's, and then you have another kind of like blip, for F's. So more people will get F's than people getting D's. Very few people get D's, and they get more getting C's. And then the only question is, are there more people getting A's, or are there more people getting B's? In other words, more than half the class would get A or B's. Well, that's because our breakpoint of a B starts at 62.5%.
Well, maybe that's not so good then.
I had to rub it. Okay, let's go back and talk about arrays. Now, we have pretty much talked about all the important concepts of arrays. So what we want to do is to think about a search algorithm. In other words, how do we make an algorithm that can search for a particular value in an array? Okay, so we'll, as usual, we'll start with an example so that we can try to do this manually and see if we can use this process to figure out a systematic way to do it and turn it into our algorithm. So once again, if you have a trivial example, it's not going to be very helpful, like this one. We have an array of 3 items. Index 0, so this is the index, and this is the value. Index 0, 1, and 2, the values, let's say, now this is unsorted, okay, because sorted arrays has a way better way to find out whether a value is in it or not. So this is not sorted. So we'll just make it clear this is not sorted. 2, 1, and 5. So I'll ask you this question. Is 5 in this array? Yes.
Yeah.
Is 7 in this array? No. Is 0 in this array? No. Is 2 in this array? Yes. Did you have to go through some sort of structured way to figure that out? No. You are using an algorithm called the eyeball algorithm. Okay? Because the example is trivial. Okay? So that means this is way too simple for you to start to really think structurally and say, what do I have to do to see whether there's a value, blah, 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 in this particular array. So let's not do this. Let's use a phone book example. Somebody's going to say, but the phone book is sorted. You just mentioned something about unsorted. But I didn't tell you what I'm looking for.
I was going to say, just use Command F. Find it.
Control F. Well, let's imagine that you have a phone book in front of you. And what I'm looking for is a phone number that ends with, I don't know, 357. Okay? A particular phone number, not beginning, but ending with the digits 357. Now, don't tell me that you have a phone book that is sorted by the last three digits, okay? Because I don't know. I know that does not exist.
You got an Excel spreadsheet, you can sort it that way.
So in that case, what do you have to do?
Look through the whole thing.
You have to look through the whole thing. So how would you look through the whole thing? Would you just kind of flip to a random page, look through the entire page, and go, nope, that is not in it, tear off that page, throw it into the fireplace, and then just randomly find another
you
page?
Probably just start at the beginning and just be like,
You usually would start from the beginning because there's no advantage of starting, anywhere else in the phone book. Starting from the beginning is just more systematic. Okay. All right. So what we'll do now is we'll try to derive the algorithm just like what we usually do. And I'll save this file first in today's folder. And this is for question, which question is that? 4. No, this is not question 4. This is question 3 or 2.
It's question.
I think it's question 2. Yeah. So I'll save this file and get rid of it. And then save this new one for our algorithm. Say linear search. All right. Do you think the approach that I just described, going through each entry in the phone book until we find the item that we're looking for, do you think it is iterative? Am I doing something repeatedly?
Yes.
We are. Okay. So our revision 1, once again, is just going to say, yes, we have some kind of a loop here, but the important part is exit when what? There are 2 conditions for us to exit here. Okay? The first condition to exit is what? When we find what we are looking for. Okay? So what I'll do is I'm just going to say that when we find what we are looking for. Is there another way to get out?
When we don't, if you rule out, when we get find anything.
Now you have to phrase it more carefully because I know exactly what you mean. I know you got the right concept, but you have to phrase it carefully. Okay? Because it's common that we just say, oh, we'll just flip the logic and say we don't find what we're looking for. But you have to qualify that. We don't find what we're looking for after we search the entire thing. Okay? Because you could have gone through 2 pages out of 600 pages of the phone book, not find what you're looking for. That will still satisfy the condition that you originally stated. But that's not what you meant. You meant you don't see what you're looking for after you go through the entire thing. Okay? So we can also say after we confirm the value does not exist. That's just the other way to say it. Because if you search through 5 pages out of 600 and you cannot find it, there's no confirmation that it does not exist. You just confirm that it does not exist in the first 3 pages. Okay? All right, and we'll even call this our first revision. It doesn't even look like programming here. Okay. That's fine, but in revision 2, we'll start to use a little bit more programming terms. So in this case, we'll say we are looking for search for a value. Let's say the value we're looking for is in variable k in an array A. In array A. Okay, so now we're starting to introduce programming terms. Okay, variable k and array A. Okay. And I'll even give you this, okay? Use variable I to control which element in array A we examine for a particular iteration. Okay, so now with all these terms, can we express this using programming terms that we have just found what we are looking for?
K equals array
A bracket I.
Yeah.
Okay, because A bracket I is the element that I'm looking at, and if K equals A bracket I, that's confirmation that the value does exist. As soon as I find the value that exists, I can get out. Okay, I don't need to go through the entire array, because once I find one, it's good enough. I just want to know whether it exists or not. Okay. The second one It's a little bit harder to express unless we know how we are searching through the array. Okay, so we'll just leave this one as revision 2, and then in revision 3 we have to specify a little bit more detail so that we know how we can utilize I here. Okay. Revision 3 has to do with, well, how am I going to initialize I and how do I move I? There are many, many ways to do it. For instance, okay, I'll give you one example here. You can skip. Okay, you can make I skip and not just increment by 1. As long as what you're skipping is a prime number that is different from the number of pages in the phone book, it will still work. Because you can always kind of turn around and back to the you can wrap around and go back to the beginning once the page number is exceeding the number of pages on the phone book. But that's kind of like convoluted for no reason. So what is a more natural way to initialize I? Where do we start?
0. I equals 0.
It just makes sense that we start from the beginning. Okay, so we say I equals 0. All right, so once we know that part, we can kind of finish the rest, because if you start from the beginning, then how are you going to change it for each iteration?
I gets I plus 1.
I gets I plus 1. Okay. If we know how we initialize and how we are incrementing or how we are changing it from 1 to the next iteration, how can I confirm that the value k does not exist in array A? In other words, how can I confirm I have just examined all elements in array A and I still cannot find it?
When you
define that
equals line A line.
Yep, I equals bar A bar would do it, but I is, well, okay, I guess I can use I equals bar A bar. Because when I equals bar A bar, it's time to get out.
Doesn't it depend if it's a pre-checking loop or a post-checking loop?
Yes. Well, there are a few things here that is wrong. So I'll explain, how it is actually kind of wrong in this case. Okay. even if you turn it into a pre-checking loop, you still have that problem here. Okay. Now the question is, should I use a pre-checking loop or a post-checking loop? If both will work, you should use a pre-checking loop. Pre-checking loops are preferred. So in this case, we should use a pre-checking loop, because a pre-checking loop would work. So to turn it into a pre-checking loop is pretty easy. We just say while, and then we kind of flip the condition itself.
make it not equal to.
So while k does not equal to a bracket I, and I does not equal to bar a bar, do the following. And then we just change the rest here to and while. Yep.
What does bar A bar stand for again?
Bar A bar is the number of elements in the array. Okay, so it looks like this will work, but it doesn't. Okay, it doesn't work for the cases where the element does not exist. The value k cannot be found. But it looks like it should work. So how
Why
can this not
wouldn't it work for that? Why wouldn't it work for the values for cases?
Let's go ahead and trace it once, and then we probably have enough time just to show why it doesn't work. And then we'll have to defer to next week to find out, how do we fix that problem. So let's go ahead and quickly trace through this with
4 minutes.
Yeah, we got enough time. I is different from bar to this one, while. Okay. We still have 2 minutes and 40-something seconds.
No pressure, no pressure.
It's alright, we can do it. My number.
It's a good thing you're a fast typer.
A, and we have an array of 1 element, 3, and then we have k being something other than that, 5. I is unknown, and this is 3. Okay. And just do. I used to go to a programming contest where they give you X amount of time to finish as many problems as possible.
Really?
So yeah, working under pressure is not unusual. Okay, we have a problem here. We got 2 minutes. We have a problem here. Oh, well, not yet. Okay, this is not a problem yet. K is different from a bracket 0 is false, is true, and I is different from bar a bar is true too. So both statements are true, right?
Mm-hmm.
We go in the loop, go to line 3, we increment I by 1, we get back to line 2. Now we have a problem. Because the first condition of the conjunction is comparing K to A bracket I. But A bracket I doesn't exist. I equals 1 at this point. So we're trying to compare K to A bracket 1, and A bracket 1 does not exist. So we run into the same problem that we talked about in the previous class, where C will treat it one way, Perl will treat it one way, and Visual Basic will treat it one way. So I'll just give you the solution because we got another minute left. Mark, exactly 1 minute. This is the problem when I have an atomic clock, because then I know exactly what time it is. Okay, so the solution is easy. All we have to do is to flip the order of the condition. But how can that work? Because conjunction is supposed to be commutative. It's just like multiplication. X times y is the same as y times x. So why would flipping the order have fixed this problem? It has to do with, in C and all practical programming languages, conjunctions are evaluated in a quote-unquote lazy way, which is also known as a short-circuited method of evaluating conjunctions. So look that up in the notes, and I will talk about that on Tuesday. Have a nice weekend, and we still have 5 seconds left. As soon as you have an answer, you don't continue anymore. That's called a short-circuit evaluation.
You said that when you try to find the number, it start from the beginning, right? Why don't we just divide the phone book by 2 and then start from the middle?
Because it's not sorted. It doesn't help you if you start from the middle.
But if you find out the number, then you combine that 2 parts together again and sort it.
But it's not, because it's not sorted.
It'd be the same thing.
You still have to kind of go through the entire array. Just think of the case where the value does not exist in the array, and think about how many items you have to go through to confirm that. Okay, so think in those terms. Yes?
Quick question, just on the Moodle.
Yes.
When you upload the files, like the text file there, what exactly is that under resources?